So if you look up here on the board, this is an excerpt taken from your book, and so we're just going to read that paragraph in class together. It says a number line can be used to show sets of natural numbers, whole numbers, integers, and rational numbers. Values greater than 0, or positive numbers, okay, are listed to the right of 0, and values less than 0, or negative numbers, are listed to the left of 0. So these are 3 examples of a number line. Okay, the natural numbers, those are the counting numbers. Those are the ones you learned when you were a little kid. Those are the numbers you can count on your fingers. 1, 2, 3, 4, and so on. Okay, the whole numbers, on the other hand, they now add 0. So it's basically all of the natural numbers plus 0. And then the integers came along, and those are the negatives. Okay, so we start with the natural or the counting numbers. Then we go to the whole numbers. Then we go to the integers. Okay, and last but not least, we have the rational numbers. In other words, the rational numbers are just a fraction. That's all they are. So when you hear the word rational number, just think of a fraction. Okay, pretty easy. All right, a rational number, the definition is a number that can be expressed in the form a over b, where a and b are integers and b cannot equal 0. Okay, so once again, all a rational number is a fraction. Could it be a decimal? Could it be a decimal? Yeah. The reason why it can be a decimal is, say, for example, I gave you the fraction 1/2. Right? What's another way to write 1/2? If I was going to write 1/2, what would be another way I could write it? 0.5, good. And see, those are the same numbers. Okay, 1/2 and 0.5 are the same thing. Those are both rational numbers. So a rational number is a fraction or a decimal. All right, so let's go and look at what we have next. Okay, a square root is one of 2 equal factors of a number. You should already know square roots. This should not be new. Okay, the non-negative square root of a number is called the principal square root. So when it asks you to find the principal square root, that just basically means find the positive value. Okay, so a perfect square. Notice what it says, a number like 64 with a square root that is a rational number is called a perfect square. So let's real quick, let's try a few here and see how well we remember from last year and the previous years. What is the square root of 4? 2. How do you find that? It's the number that's taken times itself that gives you 4. We know that 2 times 2 is 4. What is the square root of 9? 3, because 3 times 3 is 9. What's the square root of 16? 4, because 4 times 4 is 16. All right, let's look at this one. What's the square root of 81? 9, because 9 times 9 is 81. So that's what the square roots are. Very rarely, especially in Algebra 1, you will probably never need to find the negative square root. It's always just going to be the principal square root. Okay, they're just reminding you that you can have 2 square roots there. Okay. So now, let's look at the next paragraph. It says a number such as root 3 is the square root of a number that is not a perfect square. So we right now can't say that the square root of 3 is like 1, 2, 3, something like that. Okay, and it cannot be expressed as a terminating or repeating decimal. This is what the square root of 3 is. If you type this on your calculator, it would fill up the screen and then it would keep going. So numbers that cannot be expressed as terminating or repeating decimals, or they can't be expressed as fractions, are called irrational numbers. So here's what a Venn diagram looks like of the real number system. By the way, a real number is any number. Okay? A real number is any number, and so that's what that big rectangle means. All right, and so here, this Venn diagram states that you started off with the naturals. That's why it's the smallest circle. That's where you started. Then we go to another bigger circle. That's the whole numbers. Remember again, what's the difference between the whole and the natural? One has 0. The whole has 0. Then the integers came. And what do the integers now add? The negatives. Very good. And then the rationals. What did the rationals add? Fractions and decimals. Now the irrational numbers are the odd ones. Here are a few that you can write down if you want to just have a few for your own little. Most famous irrational number is pi. In fact, they still have never found the end of pi. They keep trying. Okay, here are some other ones, root 2, root 3, and root 5. What would be another square root that would be an irrational number? Can somebody tell me? Does 1 end? The square root of 1 is 1. Okay, so let's try another one. That was a good try. What's another one? Square root of? Just take a guess, somebody. There's nothing wrong. Square root of what?
7.
7, good. Perfect. Great. The reason why 7 works is because if you look up here, you have 4 to 9, right? That's from 2 to 3. So anything from 4 to 9, okay, you can't use 4 and 9, would be an irrational number. So I could have root 5, root 6, root 7, okay, root 8. What would be another square root that would work? That would be an irrational number? Square root of 13, very good. Because look at now, I go from 9 to 16. So any of those between 9 and 16 will work as well. So that's what an irrational number is. Okay, nice job. Okay, now notice what this says. It says name the sets of numbers to which each real number belongs. You could have one answer here, you could have 4 answers here. Okay, so this is going to be like your homework. This is the first type of problems on your homework. So let's start with 5 20-seconds. Is that a natural number? Nope. Is it a whole number? Nope. Is it an integer? Nope. Is it a rational? Yes. That is your answer. Can you see how that works? So let's go through with root 81. First of all, can you simplify root 81? That's the very first thing we need to look at. What is the square root of 81? 9. So now we need to go through the list just like we did. Is it a natural? Is 9 a counting number I can count on my fingers? Yeah, so that's your first one. Is it a whole number?
Yeah.
Yep. Once it's a natural, it's everything after that. So what would be next after a whole? Integer. Good. And then what's next? Rational. Very good. So if it's a natural, it's all of them. If it's a whole, it's these 3. If it's an integer, it's those 2. Okay, what about root 56? Can you simplify that? Is there a number that we take times itself and get 56? No. Okay, so then let's go through the list. Is it a natural? Whole? Integer? Rational? What's left? Irrational. So that's what you're going to say to yourself on every one of these problems. You're going to go through that step. You're going to start with natural, whole, integer, rational, and then irrational. Okay, now notice what this one says. Graph each set of numbers on a number line. Then order the numbers from least to greatest. So we're going to start with the number line. In the middle of the number line, I'm going to put 0. Okay, now I've got to figure out where each of these numbers are. So 5/3, that's an improper fraction because the numerator is bigger than the denominator. So I need to figure out what mixed number does this equal? Remember a mixed number? An example of a mixed number would be like this. Okay. 1 2/3, very good. So this is really 1 2/3. Okay, what about negative 4/3? What would that be? Negative 1 1/3. The 2/3 I'm okay, and then the negative 1/3 I'm okay. So then now what I need to go ahead and do is I need to go ahead and graph those. So I'm going to go ahead and put 1, 2. I really don't need to go any bigger than 2 because nothing's bigger than that. And so then now, 1 2/3. Here's 0. Where would 1 2/3 be? In between the 1 and 2, closer to the 1 or closer to the 2? Closer to the 2. Because it's 1 2/3. 2/3 is, over half. All right, the next one, negative 1 1/3. Where's that going to be? Yep, between the negative 2 and the negative 1. Closer here or closer here? Closer to the 1. Yep, because you're going to go 1/3 right here. Okay, what about 2/3? Between the 1 and the 0, closer to the 0, closer to the 1. Closer to the 1, yep. And then negative 1/3. Between the 1 and the 0, so right about here. Okay, so if I label these, remember this was negative 4/3. This was negative 1/3. This was 2/3. And what was this one over here? Yeah, that was the 1 2/3 or the 5/3. So do you see how I wrote those above the number line? That suffices for ordering the numbers from least to greatest. So you're done. Okay, so when it says order the numbers from least to greatest, I just did. So that's the number line and ordering. Okay, let's go through this next one because this next one's kind of a little interesting. We need to kind of simplify the numbers a little bit. We know 6 4/5, that's good. What about root 49?
7.
Very good. 6.3 repeating. And root 57. So let's think about that. I know that the square root of 49 is 7, right? I know that the square root of what is 8? 64. So 57 lies in between those, right? It's about halfway in between, a little over halfway, but close enough. So this is going to probably be a little bigger than 7.5. Okay, do you see how that kind of worked? You kind of find the two numbers it fits between. So I'm going to start with 0. Notice I'm not going to do the negatives. You don't have to have a symmetrical number line as long as you start with 0. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, time for you to get up and move. Somebody needs to come up and mark where the 6 4/5 is. And if somebody doesn't come up on their own, I'm going to pick on you. So 6 4/5. Somebody needs to just come up and plot where 6 4/5 is. Okay. Next, somebody needs to plot where the 7 is. Okay. 6.3 repeating. Squeeze it in the best you can. 6.3. There you go. Okay. And then the next one, root 57. We talked a little bit about what number that was. And then you can go. Okay, so root 57. Nice job. Okay, so here are our numbers. Now what we need to do is just write what they are next to them, and then we're good for least to greatest. What was this?
6.3.
And you could actually do this as you plot them, and that would work as well. What was this one? 6 4/5. What was this one? Yeah, which was what in the original problem? Root 49. And then what was this one? Root 57. There you go, least to greatest. Okay. Think you got that down? Do we need to look at another one? Or not? Think you got that? Okay. So the next thing, and I think this is probably close to the last thing we're going to do today. Write as a fraction in simplest form. Okay, now this has some steps, so you probably are going to need to write this down. 0.7 repeating. Okay, 0.7 repeating is 0.777 and so on. It just keeps going 0.777. So what I'm going to do in order to write this is I'm going to say that n equals. That's your very first step. And notice I left a space. There's a reason why I left a space between that and the line above it. How many digits repeat? So basically, if you're figuring out how many digits repeat, you're going to look at the line. How many numbers is the line over? 1. So 1 digit repeats, right? So that means I'm going to add a 0 to this. So since this was just n, this really is 1n, right? So if you add a 0, what does that number become? If you add a 0 right here, it becomes 10. So what I'm going to do now is I'm going to move that decimal 1 place to the right. Or the other way to think about it is take this number times 10. So if you take 0.7777 times 10, or move the decimal 1 place to the right, I now get 7.777. So once again, we let n equal the number. We count how many digits repeat. We add that many zeros. Next step is to subtract. What is 10 minus 1? 9. If I subtract those, yeah, I know I've got like those dot, dot, dots and the decimals, but what do you notice? Yeah, these are all gone, right? Those all cancel each other out. So what does that leave me with? What number is not canceled out? A 7. And so now we're to a basic equation, right? How do you solve that for n? What do you do? How would you solve that for n? Because it's kind of like if you had n plus 9 equals 7, what would you do? Subtract, right? This one is at n plus 9. This is 9 times n, right? So how do you undo that? How do you undo timesing? Divide. So I'm going to divide by 9. On the left side, what ends up happening when you divide, that's gone. And on the right side, what are you left with for a fraction? What is it? Yeah, 7/9. That's a fraction in simplest form. Okay, you can't reduce that down. So if you were to, on your calculator, type in 7 divided by 9, you'll get 0.77777. All right, so we've got another one because we definitely need another one to try. Let's try this one, 0.23. Okay, 0.23. So what's the first thing you do? Remember from before? What's the first thing I do? N equals 0.23. Okay, and you could do the dot, dot, dot if you wanted. I mean, it's the same thing. Or if you wanted to, you could put another 2 and a 3. It doesn't matter. But what 0.23 repeating means is 0.2323232323. Next step, you count how many digits repeat. How many digits repeat? 2. So how many zeros do I add? 2. So instead of it being 10n, what's it going to be? 100n, okay? So then now, on the last problem, I moved the decimal 1 place. How many am I going to move it here? 2 places. So if I move it 2 places, what does this become? 23. Good. 23.23. And if you wanted to fill in another 2, 3, you could, because I mean that's the same thing. What's the next step that you do? Subtract. Good. So if I subtract 100 minus 1, what do you get? 99. Nice job. Equals, what's going to happen here? Yep, those are going to all cancel off, and I'm going to be left with 23. So my solution will be, right, I'm going to divide by 99. And so my final solution, because my 99s will cancel here, is going to be 23 over 99. Can I reduce that down any? Because 23 is prime. So there you go. All right, now what I want you to do is I want you to turn in your book. We're not going to do the last one. Okay, I need you to turn in your book to page P10. Okay, P10. That's in the preview chapter. Okay, I want you to do for me 1 through 8, 13 through 22. Okay? 1 through 8, 13 through 22. And that will be due on Monday.